Very soon, 5 people will be receiving one Vise worth of parts to make a twin turbo Vise. And although they're very smart people, I thought perhaps some instruction would be in order to make sure everything goes smoothly. And I'm making this public to bring the whole audience along for the ride and keep the interest alive. So the first step is to mount the bushing and the nut for the 2 screws. Now these need to be separated from each other by about 3 inches, give or take, with the center line of each pair separated by 20 inches to match up with the vise. So after having done this several times, I find it best to cut a piece of scrap wood to 17 3/4 inches because then that's the spacing actually in between the 2 nuts or bushings, and you can test that by kind of clamping it together and seeing if it slides easily down the 2 screws. And that's a lot easier to use as a setup tool once you have one set attached to the bench, rather than trying to maneuver the vise with the screws into place and using that as the setup device. So that's what I would recommend. Now to actually mount these, you need to drill and tap holes for these bolts that I'm including with the vise. And this can be done either with the taps made specifically for wood that MLCS sells, link in the description, or you can go the budget route and just get a cheap metalworking tap. That will work. There are some advantages to the MLCS version. It's got a hex end that won't slip in the drill, and probably more importantly, the diameter of the cutting thread's just a tiny bit smaller, so you get a very snug, even slight compression fit with the bolt and a bit of a stronger grip. Now, the tap made by the metalworking bit, especially with the extra length that I have in these bolts, should be plenty strong. So I'm not trying to sell taps here, and full disclosure, I do get a royalty if these taps sell. So do whatever you want. So with the bushing and the nut mounted on each side, you can thread the 2 threaded rods into each nut and turn them by hand until the back plate of the vise is the same distance from the bench on each side. Next, put the outer gears on the couplers to the screws. These are the gears with 23 teeth, and put a little dot on the top. When you put the vise back together, if you put these dots on the top, then the spacing to the bench will be correct. And remember to label them left and right because they could be different. And now we'll switch to building the wooden chop. The first step is dimensioning 2 pieces that look like this. Their length is about 1 inch greater than the bench width. The width of these 2 wooden pieces is 3.5 inches larger than the bench thickness, and the thickness of these 2 pieces is 1 5/32 inch. Next, pick one of those 2 boards and lay out 2 holes, each of them 3 11/16 inches up from the bottom, 20 inches apart, and centered on the center of the length of the board. Each of these is first drilled with a bit diameter larger than 1 inch, say about 1 1/4 to 1.5 inches, and about 1/4 inch down. This is to make room for some welds on the back of the back plate. After that, it's drilled all the way through with a 1 inch diameter bit. And it's okay and even kind of better if these fit a little bit loose on the screws, so I widen them on the oscillating spindle sander. You could use a file or something to get this done also. Now you can test if it fits over the screws well. It should be pretty loose, and it definitely should not be pushing the screws out of parallel. That is something that I ran into. If that's happening, then file away the part that's pushing on the screws. With the back plate in place on half of the wooden chop, you can mark the center of each of the outer 6 holes on that back plate and trace the middle 3 penetrations as well. The center one's a diamond, just mark it out. Material needs to be removed for some fasteners. That's why we're doing this. For the 3 center penetrations, I just use a 3/4 inch bit. In the very center, just drill down about 1/8 of an inch, and on the 2 mid sides to the left and right of the center, drill down about 1/2 inch. And on the 6 outer marks, first they're drilled with a 7/32 inch bit, and these are drilled about 1/8 of an inch shy of a through hole. And then these 6 are tapped with that same 5/16 coarse thread tap that was used to mount the nut and bushing at the very beginning. Now take this board we've been working on, put it on top of the second board and mark the location of the two larger holes for the screws. Drill these out on the second board with 1.25 inches or something larger than 1 inch. We just need to get this material out of the way so that we can lay out some cut lines with the back plate of the vise. And then cut this out on the bandsaw. Now people are threatening to throw away the metal front plate of the vise that I worked so hard on and just replace it with something clear. That's fine if you are planning on doing that, but these cuts get to be a bit more critical if they're going to be visible through that clear front plate that you're building. If you're using the metal one, you can be a bit sloppy. Next, put the back plate of the vise in place on the first piece that we worked on, and the two can be glued together. Now back to metal part assembly. Fit a bushing on the center pin as I'm showing here. It's the only bushing that fits. Then fit the center back gear over this bushing. This is the gear with 32 teeth. And put 2 washers on the back side as I'm doing here. It should spin freely, and the square end of that center pin fits into the square penetration on the center of the back plate of the vise. And to finish this off, there's a threaded hole that accepts a screw on the back end of that center pin. A little bit of Loctite is in order, as well as some elbow grease to tighten this up and make sure that it stays in place. And if this all went together correctly, that center gear should be spinning very smoothly, but not be wobbling. Now it's time to couple up the largest gear with 45 teeth with the gear with 28 teeth. You do that by placing this gear coupler in the center and putting them together. They only fit together one way because the spacing on the 2 pins is different, so this makes sure they're aligned right. And then there's a bushing that fits into each side of that assembly of 3 pieces, the coupler and the 2 gears. These are the only bushings that I've included that fit. And then lastly, there's a center standoff pipe that goes inside here. You're going to want the one with a thick wall for this. There are 6 with thin walls and 2 with thick walls. You're going to use the thick-walled ones for these gear assemblies. Now it's a good idea to set the back plate of the vise up on a sawhorse or a stool or something so that the screws can hang down, and place 2 of these assemblies that I just put together in between the center gear and the outer gears. Now at this point we're going to get all the gears aligned up, and there is some potential to get things wrong here, so this is important. First, it's important to notice that the gap between the holes on the gears that couple to the pins in the coupling assemblies are not the same distance from the center. And what we want to do is set up the larger gapped hole pointed straight up on both of those coupled gear assemblies. If you do that and you have the marks that we made at the beginning on the outer gears facing up, everything will go together and work smoothly. Now place some washers on each of the back ends of the outer screw shafts. These hold the outer gears in place. They do have some tendency to slide around before the vise is tightened, but you can see here from my clear version that they stay in place well once everything's put together. Now to the front plate. Take the shorter and more finely threaded 5/16 inch screws and put them in the center 2 holes on the front plate like I'm doing here. And now the front plate and the back plate can be put together. Now the center aligning pin needs to fit in the gear that's attached to the front plate, and the 2 screws that we just put into the front plate need to fit into the 2 coupled gear assemblies that we just put in place on the back plate. It's easier to see from my clear version, but it's probably going to be necessary to turn the handle a bit to get that front gear to slip through the 2 larger mid-center gears. Once this is done, the 2 center bolts can be tightened. They engage threads that are actually tapped into the back plate of the vise. And they stick out far enough through the back of the vise that you can put these 2 nuts on the back end that will make sure everything's locked into place and won't ever move. And at this point you can test out the transition from high to low speed, make sure that's working and that everything turns with low friction. One more step before installing on the wood, we're going to get these thinner walled standoffs in place. The way we do this, slip it in place on one of the outer holes and put one of the longer threaded bolts through the front and back plate and that standoff. Now that metal assembly can be put onto the wooden chop, and the 6 bolts can be threaded into the taps that we made earlier on the back half of the wooden vise. Once again, test the transitions between high and low speed and make sure that everything's turning easily. If it's jamming up at this point, the most likely culprit is that one of those washers on the outer gears slipped out of place and is jamming on the shaft of the screw. But if that looks good, we can get the vise in place, make sure that the threads are lined up and the distance is right. You don't have to assemble the handle. I did this, it'll come assembled, but it's a piece of all thread through a pipe with these 2 ends tightened in place if for any reason you want to take it off. Now we give it one more test run to make sure everything's working with it threaded into the nuts. Now if there was really low friction when the vise was free out of the nuts, but now it's jamming up, that probably means that a bushing or a nut is in the wrong place. Now there is a little bit of play in between the nuts and the bolts that are holding them to the bench, so loosen them up and try to shift them around a little bit if you are running into that issue. To finish this off, you fine-tune the wooden portion. I'm flushing it up with a plane to the top of the bench, and then I mark the sides, take everything apart, and cut those on the bandsaw. Now, one last thing to do. As sturdy and as tight tolerances as you make a vise, you're always going to have a little bit of top to bottom racking. And this is very easy to compensate for if you just plane off a bit extra material at the base of the wooden chop. So what I'm doing with everything taken apart is putting a board in the space where the metal goes that's just a little bit proud of the bottom surface, maybe not even quite 1/8 of an inch. And I'm passing it through a planer, and that will impart that same slant on the face of the wooden chop that meets a workpiece, just to compensate for that slight bit of top to bottom rack. And lastly, I included some of this rubber cork material that is just extremely grippy. I would recommend putting this on the front and back clamping surfaces of the vise and use contact cement. There it is. Good luck.